In today's lesson, we will be taking notes on similarity shortcuts. There are going to be three we're going to go over today, and they're similarity shortcuts for similar triangles. The first one is angle-angle similarity. Basically, for this one, if you have two corresponding angles that are congruent, then the triangles are similar. So we want to have two corresponding angles that are indeed congruent, meaning they are equal. For example, on the directions say we want to determine if the example below is similar by angle-angle similarity. If it is, we will have to write a similarity statement. Let's go ahead and take a look at our angles. Well, right away we have angle A, which is 75 degrees, and so is angle D. So that's one angle pair that I know are congruent. Now we want to go ahead and have another pair congruent as well. Well, 74 and 31 do not match up, so we have to kind of take a look at our other angles of C and E, and we can using what we know about triangles. Remember that in this triangle ABC, all the angles must add up to 180. I have two of them, I'm missing one, so I subtract the two I know from 180. 180 minus 75 minus 74 gives us 31 degrees. So that is going to be my angle there of 31 degrees. Well, that does indeed match up with angle F, which is 31 degrees as well. So because we have two angles that are congruent, we can say yes, that these triangles are similar by angle-angle similarity. To write this statement, we write a triangle symbol, and then we want to talk about our first triangle. You can go in any order for this one, but what matters is for your second triangle in your similarity statement, you have to match those letters with the corresponding congruent angles. Well, angle A was congruent with angle D, so I will write D first after this triangle symbol for the second triangle. Then B went with E. Those were the two I didn't highlight, but they still match up together. And then C went with F. Those are my green ones, the ones that were 31 degrees together. So it has to go in that order. ABC is similar to DEF if I wrote it that way, ABC in the beginning. We say yes, triangle ABC is similar to triangle DEF by angle-angle similarity. And just so you know, when we see these squiggle marks, that is our similar symbol. So just a reminder, that is the symbol for similar. Example number 2 over here, same thing. We want to determine if the example below is similar by angle-angle similarity. If yes, we want to write that similarity statement. Well, right away I have one angle here. I have that angle V is 1 mark. Same thing with angle W. So those are congruent. I need one more angle. Nothing else, no numbers are given to me, but I do know in bow tie shapes, every time we have a bow tie shape, we get these vertical angles. They're the angles here that will match up and be congruent across from each other, almost like they're vertically across from each other. Because I have a bow tie and I know I have vertical angles here, I can mark in those angles. I know they will be congruent because vertical angles are always congruent. So in the end, I get two angles here. So I can say yes. Triangle, again, choose one to start with. I'll start with the left one. VWX is similar to triangle. Well, let's match up the letters. V went with Y. They were the same color, same mark. Z went with W. Those were the ones I didn't mark. And then X would match up with X because they had two marks on each. They had two marks on each, and we would say by angle-angle similarity there. That's our first method. Moving into our second now. For the second out of our three triangle similarity shortcuts today, we have side-side-side similarity. For this one, if all corresponding sides are proportional, then the triangles are similar. So we're going to look at all three sides and match up and see if they're proportional to their corresponding ones. So our example 3, we have to determine if the example below is similar by side, side, side. Similarity, if yes, we write that similarity statement. So we're going to go ahead and take a look. When I talk about corresponding sides, I want to match up my sides. How I do that is I take the smallest number. I'll go ahead and put one symbol around that. I chose a circle. That's going to match up with the smallest side in my second triangle. Well, looking at the numbers, 6 would be it. So my first ratio is 3/6. Okay, let's take a look at another one. Let's go to our second largest number in that first triangle. That's going to be 4. I'll put a different symbol around it. I chose a triangle. Match it up with 8, our next number in the sequence in my second larger triangle here, 4/8. And when I write these fractions, I want to stay consistent that I'm going to have everything I know about triangle PQR in the numerator and every side coming from triangle TSU in the denominator. We go ahead and keep going to our third and largest side. I'll use a different symbol. I'll do a cloud here. 5 is the largest of the 3 sides in QPR, and 10 is the largest of the 3 sides in TSU. So again, put the smaller 5 over the larger of 10. Those are my 3 ratios. I want to go ahead and see if I get the same decimal when I simplify and do this in the calculator each time. When I do 3 divided by 6, I get 0.5. When I do 4 divided by 8, I get 0.5. And when I get 5 divided by 10, I get 0.5. They're all the same decimal, so that means they're all the same proportion and ratio there. So I go ahead and write my statement. Yes, triangle QPR is similar to triangle. Well, QP was my first side, so I go TS, SU matched up, and TU matched up with the third side there. And it was by side, side, side similarity. Awesome. So again, with those letters, how I did that, QP was my pink side, and so was TS. Then PR was the blue side, matching up with SU. And then first and last letter, QR, matched up with TU. So I know I matched up the correct pattern by the correct siding there. Let's go ahead and look at my second example here, number 4. Going again to start with the smallest side here. So I'll start with my first symbol. I'll choose a circle. My smallest side in this CDE is going to be 30. Smallest side over here, smallest number is 24. So I'll put 30/24. Again, I just do that by matching up the smallest number in each triangle. Then the next one in my proportion will be the second smallest number. Put a triangle around that, 32. Matching side would be 25, giving the matching symbol of a triangle. And you could choose any symbols, I just choose these. Last side would be 35, that's the largest number in CDE. And that matches with 28 in my FGH. Remember, double check that everything in the numerator came from your sides of triangle CDE, and everything in your denominator came from your sides from triangle FGH. We go ahead and then do our division of each ratio here to see if we get the same decimals across the board. When I do 30 divided by 24, I end up getting 1.25. When I do 32 divided by 25, I get 1.28. When I do 35 divided by 28, I get 1.25. Two of them are the same, but not all 3. So these ones would not be similar. We don't have to write a similarity statement since they are not similar triangles there. We need all three sides when they match up with their corresponding sides to be the same decimal when we straight divide these three ratios. Now we're moving on to the last similarity shortcut we have today. The last of the three triangle similarity shortcuts is side angle side similarity. This happens if two corresponding sides are proportional and the angles between them are congruent, then the triangles are similar. For example number 5, the directions state that we want to determine if the example below is similar by side angle side similarity, and if yes, we want to write that similarity statement. So we go ahead and look at our smallest side first. I have a small side of 8. I'll choose a symbol of a heart to go around it. That matches up with my side of 6 over here. Again, I chose those because they were the smallest sides in each of our triangles here. So I have 8 over 6 to be consistent. I'm going to keep any information from triangle KJL in the numerator and anything from my smaller triangle NMP in the denominator. Okay, let's keep going. We want to match up our second side. We need two corresponding ones. Well, my side of 20, I'll put a box around it, goes with my side of 15. 20 goes first because that was for my larger triangle, KJL, and in the denominator will be my 15 that was in the smaller triangle, NMP. I go ahead and simplify those fractions to see if they get the same decimal, if they are indeed the same ratio. 8 divided by 6 comes out to be 1.3, and 20 divided by 15 comes out to be 1.3 as well. I have two sides that are corresponding. So I have that condition up here. Two sides that are corresponding have the same ratio. Now I want the angle between them, and I do have that angle each time. Angle K and angle N are sandwiched between my two sides there. So that would be my angle between them being congruent. So I have both conditions. So I go ahead and say yes, that the two triangles are similar. To write my statement, I have K, J, and then L. Have to match up here. Well, angle K goes with angle N. That's the one with one mark in each triangle. So N must go first with K. J is that obtuse triangle, matches with the obtuse triangle of M. And then P over here goes with L. There and there. That's my similarity statement, and this time it was by side angle side similarity. In example number 6, we have to determine if the example below is similar by side angle side similarity, and if yes, we're going to write that similarity statement. So some might be wondering where the two triangles are. One is here, ADE, and my other one is ABC, the whole triangle there. That's where I get my two triangles. So I'm going to go ahead and take them outside of each other and mark their sides. So in this triangle ADE here, I have 15 and 12 known. Those are my two sides there. For ABC, that large triangle, I have 25 and 21 known. So those are where I get my two triangles from. Now I can match up my parts here. The smallest side in my orange triangle ADE is 12. So 12 will match up and go with 21, the smallest in my second triangle ABC. You match up the smallest side with the smallest side. We want to see if that's the same ratio, the same decimal as the two largest sides we have here that were given to us. So that would be 15 matching up with our 25 in that triangle ABC. So as a reminder here, everything in my numerator is about the smaller triangle ADE, the triangle within the triangle, and everything in my denominator was about triangle ABC. So I go ahead and simplify those fractions. 12 over 21 simplifies to 0.57, and 15 divided by 25 simplifies to 0.6. They're not the same decimals, so these are not going to be similar. But just to let you know, they did have a congruent angle. It would be angle A here between the two sides because angle A was the same angle in both. It was shared angle because the triangles were in each other, but both had that same exact measurement for angle A. So I just wanted to point that out, but these were not similar because these sides were not proportional to the corresponding ones.